It was just a fireball and travelled so fast.
I just saw flames all up on the hill behind my house.
It was Armageddon, I'll tell you. Fire coming in, burning all around us.
Alaska, Arizona, California, Montana, Oregon, Australia, Brazil, Canada, Greece, Russia. These are just some of the places where, in recent years, wildfires have raged out of control. NASA satellites detect more than 1 million large fires worldwide every year.
The Western United States, for example, has seen larger fires in each of the last several years and more intense burning. And many times those fires spread faster, making them more difficult to put out and more dangerous for the communities who live in that vicinity.
In many cases, the blazes are set by human activity, but sometimes policy fuels the flames too. Consider California. The state's forests are overgrown in part because of past federal policies of putting out wildfires rather than letting them burn. Some of these policies were enacted in response to a devastating fire in 1910 in which millions of acres burned. More than 80 people died. Years passed and suppression became the go-to strategy for dealing with fire.
It only takes a minute to wipe out a century.
Initiatives like Smokey Bear urged Americans to help prevent forest fires.
Only you can prevent forest fires.
In 1974, Congress passed the Federal Fire Prevention and Control Act in an effort to save lives, and that plan worked. Around that time, according to the act, fires of all types killed more than 12,000 people each year. Today, according to the U.S. Fire Administration, the death toll is lower, but
part of the reason we see increasing fuels and increasing extreme fire behavior is that we have a legacy of putting fires out and allowing fuels to grow, permitting fires, when they do start, to get out of control.
Overgrown forests have an abundance of small and medium trees known as ladder fuels, which can make fires more dangerous.
Ladder fuels would allow a surface fire, burning often slowly along the ground, to transition into the canopy, where it can spread more rapidly. And when those trees are burning, the embers that are blown by the wind can ignite the neighboring trees. They can also be spread further downwind.
That's part of the story of California's 2018 fire season. The deadly campfire was fed by dry weather, fast winds, and ladder fuels. According to recent research, 20 million acres of forest land, or nearly 20% of California, would benefit from what's known as fuel treatments. Land managers can limit the fuels that could create large, fast-moving fires in several ways, including thinning out vegetation, think logging or clearing brush, prescribed burns, where small fires are set deliberately, or letting natural wildfires in unpopulated areas run their course under the watch of local firefighters. But clearing out brush can be expensive and labor-intensive. For instance, many of these trees are small in diameter, so they don't have commercial value as timber, and there's little financial incentive to remove them. And federal policies have historically favored putting out fires as soon as they start, to keep people safe.
Maintaining that balance of different ecosystem types and different fire frequencies is more difficult when we move into areas with more dense human populations. And so the wildland-urban interface is really where these two challenges meet, where people are living in communities against landscapes that historically have had fire activity. Those are landscapes that are very difficult to protect when fires do start.
One of the factors affecting California's wildfire season is new housing construction in fire-prone areas. Climate change is adding to the problem too.
Where fuels are abundant today, and where climate change is leading to warmer and drier conditions, we are already seeing more extreme fire behavior.
According to recent federal data, the last decade was the warmest on record. During the summer of 2020, fires burned in the Arctic as parts of Siberia broke the record for the highest temperature ever recorded above the Arctic Circle.
They're almost always too cold and too wet to burn. So as those landscapes, which are warming 3 times faster than the rest of the planet, continue to warm and dry, we certainly expect to see more fires in those remote landscapes directly in response to climate change.
In August of 2020, wildfires, most of them sparked by lightning, raged out of control across California. Earlier in the year, state officials had warned of high fire danger caused by a dry winter and warm spring. It's a pattern scientists generally attribute to climate change. In May, the mountain snowpack in California's Sierra Nevada was just 13% of normal. And it's not just 2020. Half of California's 20 most destructive wildfires have happened since 2015. Across the forests of southeast Australia, NASA mapped more fires between 2019 and 2020 than they had in the last 16 years. The fires were fueled by extreme heat and drought. Hotter, drier weather sucks moisture out of the trees, grasses, and other fuels, making them more flammable. And this is making fire management all the more complicated.
So as conditions that allow wildfires to spread are lasting longer across the United States and elsewhere, there's a shorter and shorter window where active management could happen under conditions that wouldn't risk fires escaping and spreading into lands as a wildfire.
That means fighting fire with fire might not be an option for certain regions anymore. So to help with wildfires, researchers are working on algorithms to improve forecasting.
If we can anticipate the timescales and the locations where fires are most likely, we have the best chance of trying to mobilize and prepare resources to anticipate fires and make a more timely decision about which fires to put out and which to let burn.